Good morning to all the professors and head of the departments. My sincere thanks to our beloved principal for giving an opportunity to talk in the Jnanavardhana. It's very unique kind of program of BMSITM, which was initiated by our honorable principal. My talk today is on blockchain, smart contracts, and chain codes for industry, business, and government applications. While people are talking about the blockchain as a disruptive technology, while people are talking about in the year 2025, 10% of GDP is due to blockchain technology, when many of the international analysis have claimed blockchain is going to redefine many of the sectors, including cyber security, then it's our cup of coffee to have the blockchain, how disruptive it is, what are its different applications, how actually we are ready with the blockchain technology at the Indian level and the international scenario that we want to look into the things, various aspects of it. Coming to the presentation flow, so I would like to explain briefly what is a blockchain and its history and evolution, types of blockchain, prerequisites of blockchain, use cases of blockchain, how we have to shift from tradition to the blockchain technology, why blockchain is essential, benefits of blockchain, what are the key industry problem blockchain solves, status of blockchain in India, advantages and the limitations of the blockchain. Friends, we know that blockchain is a distributed database which maintains the data in a very integrated manner, in a distributed manner, and which keeps the data securely, tamper-proof, and revision of data once created is not possible. We know that blockchain is the primary technology behind Bitcoin. Blockchain was earlier created for the Bitcoin. Bitcoin works on blockchain. All these basics we know. Digital currency, Bitcoin, has given rise to different kinds of potential applications. We have both types of applications sides. I mean to say, one is a Silk Road, dark web, where illegal activities happens. Another is a road which definitely enables us to come out of the fight, establish the trust among the business, and do our business in a well-trusted way. That is the another side of the Bitcoin. We want to take up the best side of the coin, and just we ignore the dark web and Silk Road of the Bitcoin technology. That's why blockchain has been taken out of the Bitcoin, and we think of blockchain as a distributed ledger technology which enables us to implement smart contract, enables to have consensus framework, single source of truth, and secure. Keeping these things in our mind, we can say the blockchain is changing the way technology is solving problems across different domains and industries. There are key points that we need to understand with respect to the blockchain. Blockchain is important because it is, if a public blockchain is available for anyone to access, data can be added but cannot be altered. To add data, validators, miners have to verify the transaction. Transactions have to be approved by majority in the network. No central authority has control over the information, and privacy is protected by cryptography. These are some of the points which has made the blockchain a unique and disruptive technology. If we analyze our various business, in the world of business, what is deficit is a trust model. You cannot buy the trust, you cannot sell the trust, but you can establish this trust using the blockchain technology. Reason why blockchain is admired so much is because of its decentralized nature. It is cryptographically secure, immutable, so no one can tamper the data inside the blockchain. Blockchain is transparent because everybody is given an access, especially in the public blockchain, and the transactions of the blockchain is a copy of the transaction of the blockchain is with the all participants. We call decentralization, transparency, and immutability are as three pillars of the blockchain technology. The information is not stored at one single point is a best benefit of the blockchain technology. Transparency, it adds the extra much needed level of accountability which is required by some of these biggest institutions. Immutability, it means that once something has been entered into the blockchain, it cannot be tampered with. In 2008, when a person or group of individuals called Satoshi Nakamoto have first developed the idea of Bitcoin and the blockchain, and this cryptocurrency has solved several of the fiat currency problems, especially the digital currency problem of double spending. This has given access to anyone. It has protected using cryptography. It's decentralized, ensures users anonymity. And we call the technology which is having these characteristics as the blockchain. Coming to the history of the blockchain, the first collection of transactions, the first block, what we call Genesis block, is created, and it is a crucial concept of the blockchain in January 2009. A Bitcoin development is registered as a discussion topic on the free node in October 2009. First Bitcoin purchase is made in May 2010. Bitcoin continues to increase its value in February 2011. Bitcoin magazine launches. There are enough people talking about Bitcoin to justify dedicated media outlet in February 27, 2012. These are some of the developments of the Bitcoin or blockchain. Now, to understand why blockchain is required, why smart contract is required, better to take up some use cases which are very realistic and it is out of our knowledge. Let us first talk about the banking transactions that all we are aware of. Arvind Narayanan, a professor in the Princeton University, has worked on de-anonymization and has given some concepts, and he is the one who has spoken about the frauds that may happen in the bank. That's why I have put his name, the bracket, is showing my gratitude for his innovative ideas and addressing the problem. Let's first talk about the banking. As we have already told, how do you transact in a bank? We write a check, for example, or we do internet transaction to pay a payee. Bank checks if you have balance. If transaction amount is less than your balance, transaction happens. Otherwise, transaction becomes invalid. If the transaction amount that you want to make a transfer is less than the balance, then credits pays account by pay balance equals pay balance plus transaction amount. You can check your transaction list online or check the monthly statement. But who maintains the ledger is the question. Obviously, the answer is bank. What if bank allows an invalid transaction go through? And if you did not authenticate the transaction, your balance was not sufficient, but transaction was made. How do you address such cases is the question. Bank frauds, you find a check which was used to pay someone, but you never wrote the check. Someone forged your check under signature. You did sign a check for X amount, but the amount field was modified. How do you prove to the bank that an extra zero was not there in your signing time? The monthly statement says that you did a transaction, but you did not recall, or amount of a transaction is different from what you had done. Someone got your password and possibly redirected OTP to another SIM. So this fraud, bank may or may not show its responsibility. Bank employees themselves might have done something wrong. How do you argue to the bank? How do you convince that the bank is you have not done, but the bank has done? How do you argue that amount was modified? The question of integrity. Finally, do you tally your transaction when you receive your monthly statement? Most people will not do this checking. So for all these things, so we can say the blockchain is the answer, because blockchain allows, if the existing bank is implemented with the blockchain, bank will not exist at all in the future, and bank will not be serving as intermediary, and the ledger will be with the very participants. And since every participant, every node in the blockchain will be having the same copy of the data, so it establishes the trust. Let us take another example of supply chain and provenance. Benjamin Herzberg and the team of authors has presented a white paper, Solution for Transparency and Product Supply Chain, and the paper was published in November 2015. Keeping this as a basis of solution, let us see a problem. The problem appears to be very simple. You buy an ice cream from a restaurant from supplier B. Supplier B actually transports ice cream made in company's C's factory. Upon delivery, you have been finding that your ice cream is already melted. So if this kind of supply happens in a large quantity, especially in case of a restaurant or in a hostel where the students are very much particular about the quality of what you supply, our restaurant, when we go to a restaurant, we never accept the melted ice cream. Then who is responsible? What is the role of blockchain in this? How you can solve the problem with the IoT? How you can solve the problem using the cloud technology? And how actually the blockchain solves this problem in a very different way, establishing the trust and identifying who is actually responsible. Let us see how these things are possible. Supplier B is keeping it too long on the delivery truck. Supplier B has kept for a long period of time because of the different issues. Ice cream has melted. Supplier B's storage facility has a temperature problem. Supplier C says it is supplier B's fault, as when picked up, ice cream was frozen. Supplier B says that when received, temperature was too high. C must have stored it or made something wrong. So everyone comes with their own reasons, but temperature sensors in B's truck and storage C factory sensor data is digitally signed by the entity where the sensor is placed and put in a log. So can you check the log, or can you identify if log details are modified? These are the different problems. Supply chain and provenance is a solution given by Benjamin Herzberg, where every physical product comes with a digital passport that proves authenticity, origin, journey of the product, and avoid double spending of the certification. So such an application is being developed at the various companies. Let us take a land record. So another case, we have might have watched a film, movie Khosla Ka Ghosla, where a common man willing to have his own house, but he gets into a problem because of the various land record issues. A common man or any person who is interested to buy a piece of land should be given a clear land with clear title, and a right registration should happen. Someone else claims it as the claims as the owner of the land, but when you have purchased and paid the full money, after that you'll come to know that he is not the actual owner, and the land registry officer says that mistakenly they have registered with the wrong person as the owner to the new owner. So these are the certain problems. Again, who is held responsible? First person goes missing, and can you make the land the government employees as responsibles who might have changed the land record? This is another problem. So you have seen in 2016-17 the problem of privacy in the Aadhaar, and you know that KYC, e-KYC logs are in many cases it was changed, and finally the compendium of regulations circular guidelines was issued by the government of India in 2018. So after that, electronically our KYC details can be downloaded, but still such application needs the blockchain implementation. Let's go to the another use case, a student online grade submission and management system. So you know that the professor, course maintenance and grade given by the professor, for example. So if it is altered by the hackers or so then it's going to create a lot of problems in the university grade system. These are all the use cases where you need a blockchain. Coming back to the trust model. So if you think of the trust model here, the trust model can solve all these problems. Trust we cannot simply trust the bank, and do you trust your bank to not to take small amounts from your balance all the time? Do you trust the Department of Land Records to keep your records integrity? How it is possible to trust all these peoples? So simply people will not trust. Can we trust local system admins not to go around and change settings, leak passwords? This may happen. When we say patch management system of our enterprise applications, so how do we trust that the patch that we are implementing is having a digital certificate? Who will ensure all these things? Who put them? Do you trust your employees to do the correct thing and not put a malware as a patch? All these things are the questions. So obviously, we think a trusted third party as a immediate answer. You become the central trust party, keeping track of all the transaction, and you are arbitrating validity of the transaction. So if we ask one single person to track everything, is it possible to trust the person? So it is highly difficult. Coming back to the question, the case of the supply chain, especially in case of ice cream supply chain to restaurant A from factory C via supplier B. So here from ice cream factory and storage C to restaurant A, so B is supplying. So ice cream is melted. Let us take the case of ice cream is melted. We want to find out the person who is actually responsible for this. So what can go wrong? IoT sensor data. Suppose if you think of using the IoT, right? So let us say we use IoT to create non-repudiation. So use IoT sensors which sends real-time data to the server at restaurant A periodically to show the factory and truck temperature to the restaurant A. Suppose if we are taking this, then what are the things can go wrong even when you use the IoT? We know that IoT sensor data may be intercepted by a middleman, man in the middle attack, and changed before it reaches the server. IoT sensors are vulnerable to replay attack. Suppose if our front door is working with the infrared rays, so that can be copied, and if you use the same infrared rays, and the door may open. So such replay attacks are possible in case of IoT. What the server gets purportedly from factory C may be manufactured by supplier B. Question of authenticity. So if a restaurant A claims that C's temperature reading shows that ice cream was melting in the storage, C can say that message you received is not from me. There was a message, there was a man in the middle attack. We call it as a repudiation. So restaurant A will not be able to pinpoint anyone in the supply chain with full confidence. That's the main problem in the supply chain. What can be done as a solution? The first level of solution is use message integrity. That means use hashing. Use digital signature of the individual IoT devices for authenticity purpose and non-repudiation. Assuming the digital signature cannot be forged, private keys are kept safe. So with that assumption, we can use the digital signature of the individual IoT devices. Use authentic time stamping with the IoT data before hashing for integrity. So these things can be done. And so this is one level of solution. Again, the concurrency issue in this case, because A has other suppliers, for example. So A is a restaurant, he may be having other suppliers. B and C may be having multiple other consumers of their services. So this creates what is known as n-square messaging problem. So therefore, such problem we have to rectify. So you need to have a solution for this. Have a trusted authority or a cloud provider to become a published subscribed service provider. So here again, the cloud, how do you trust the cloud becomes the question, because we know that cloud gives the security, but there is no transparency and privacy protection on the cloud. Therefore, we need a framework which data is where data is crowdsourced and validated by the crowd for the crowd. So using the blockchain technology, this can be done where the distributed consensus algorithm is implemented and all messages coming concurrently are ordered, and some messages, if they are malicious, and such messages will be handled using Byzantine fault tolerance algorithm. So when we consider this use case, a distributed record keeping can be made. So let us say restaurant A, supplier B, and the storage C. So among them, distributed record can be maintained, and trust model can be implemented. That means a blockchain, a permissioned blockchain may be implemented, as a private blockchain may be implemented. And data integrity, no one can tamper the data if the blockchain is implemented. And the suppose if you are able to apply the digital identity for the items, then it may solve several other problems. You can say blockchain has application in various fields and sectors: supply chain, food industry, okay, healthcare, smart grid, etc. When we say the global level, banking and capital markets industry adoption of blockchain technology, 44.6% have adopted the blockchain. Government, 9.7% across the world has adopted the blockchain. Insurance, 7% and 5.8%. These are the some of the adoptions of the blockchain technology. And at the global level, adoption across the globe for land registration and identity management, digital currency payments, governance, healthcare, and election or voting system, the blockchain has been adopted. And we know that blockchain technology, how it works, we know. So we know that a block is having the version information, nonce, previous block information, timestamp, Merkle tree to record the transactions of the block, these things. Creation of blocks, how many transactions in a block? It is actually generally 500 transactions in a block in a size of 1 MB of the block. So I will go to the concept of today's talk, that is the smart contract. So let us take the smart contract. As we have seen, one use case of the supply of ice cream. Another use case that is particularly interesting for business application is executing contracts among a closer set of participants. So say for example the vegetables supply. So this one use case. So here let us see how we can use the smart contracts. So basically we want to know what is a smart contract. We can write the script of the terms of agreement, terms and conditions in the agreement in a coded format in a smart contract. And we expect these code itself as the law, as the rules for executing the contract. And we expect this smart contract to be executed automatically. You can extend the script to ensure smart contract execution. Execute a transaction only when certain condition is satisfied. So in smart contract, as usual, we are having seller and buyer. Match buyer with seller. Contract receives assets. Contract distributes the asset. This is what we call as exchange. And let's go to the definition of the smart contracts. Smart contracts, as we have seen, is a self-executing contracts. And this concept was first introduced in 1998 by Nick Szabo, an American computer scientist who invented a virtual currency called Bitcoin in 1998. He defined the smart contract as computerized transaction protocol that execute terms of a contract. Smart contract renders transactions which are traceable, transparent, and irreversible. These smart contracts are implemented on the blockchain. Contracts, as we have seen, were proposed by Nick Szabo. People said that Nick Szabo himself has implemented Bitcoin and blockchain technology, but he has not agreed that he is Satoshi Nakamoto. But Szabo defines smart contract as computerized transaction protocol. He extended this as a functionality of electronic transaction methods such as point of sale to the digital ring. As we can see, smart contracts allows the will not allow the intermediary. It will be implemented on the blockchain. This will replace lawyers, for example, and you can think of a smart contract in a simplest way. To describe the smart contract is compare technology to a vending machine. In general, we go to a lawyer or a notary, we pay him and wait while you get the document. With smart contract, you simply drop a Bitcoin into the vending machine, that is our ledger, and you a screwdriver license or whatever drops into your account. So smart contract not only defines the rules and penalties around an agreement in the same way that a traditional contract does, but also automatically enforce those obligations. This is how we can think of the blockchain working. Smart contract is working on the blockchain. Smart contracts are written as code and committed to the blockchain. The code and conditions in the contract are publicly available on the ledger. Everybody can see what are the terms, conditions in the contract. And when an event outlined in the contract is triggered, then it works. For example, an AMC given date of expiration, it can tell us when due to some trigger it works. So regulators can watch the agreement that is working on the smart contracts. Ethereum is a public. We can implement the smart contract on a public Ethereum blockchain, or we can implement it as a private blockchain. On an Ethereum, Ethereum is basically a decentralized computing platform. It generates a cryptocurrency token as Ether. We need to have the token. Programmers can write, once we have the token, we can write the smart contracts in the Ethereum blockchain. These contracts are automatically executed according to the code that we have written. Bitcoin blockchain stores a history of Bitcoin transaction. Ethereum blockchain stores Ether tokens in people wallets. Wallet is basically helps you to store your Bitcoin tokens and private and public keys in that. And it also helps to store the recent state of each smart contracts as well as smart contracts code. That's how the users can see the smart contract code and the keys in the token. In the wallet. A blockchain is a distributed ledger stored in multiple locations. So this means that a smart contract data is stored by those Ethereum nodes. If you create a smart contract, then an application on the blockchain is stored and we can run in a decentralized manner. Smart contracts are applications that run on actually Ethereum virtual machine. This is a decentralized computer. So computing power is provided by all those Ethereum nodes. Any nodes providing computing power are paid for that resource in the Ether tokens. So computing power, people or the nodes can come forward to provide the computing power. When we talk about the contracts and its implementation, now the design question comes, the execution of the contract comes. The execution of the contract has to be made in all nodes is the question. Generally, we execute the smart contract at all nodes and propagates the state to the others, try to each consciousness. This one approach, basic approach. But sometimes it may not be required to execute the contract in all nodes. The state of the contract may be upgraded to all the nodes. But the participants, the blockchain nodes, need to understand the state of the smart contract, propagate same state to all the nodes, verify that the state matches, that happens as a part of the consciousness. Do you have sufficient number of trusted nodes to validate the execution of smart contracts? In a public chain, if a smart contract is implemented, so this type of question arises. If the smart contract is implemented in a private chain where the people who are participants are known, then the problem of trust won't comes there. So now again we are going back to the question of, do we really need to execute contracts at each node? So as I told, it's not necessary. We need to synchronize the state of all the nodes. So broadcast the state to all the nodes. We just need to synchronize all the nodes. So when we think of synchronizing with a consciousness, again, distributed consciousness has to be applied because of the distributed nature of the nodes. Use state machine replication, execute a contract at subset of nodes, identify some of the trusted nodes and execute the contract at those subset of the nodes, and ensure that the same state is propagated to all the nodes. That's one idea of doing it. So distributed state machine replication, in this case, place copies of the state machines on multiple independent servers. So say these three servers shown in this figure are actually executing the contract. Multiple copies of the state is placed in those servers, and then it will be shared among the other nodes in the blockchain. So here we are talking, in this slide we are talking about permissioned blockchain and state machine replication. Permissioned blockchain, permissionless blockchain. There are two types of blockchain. In a permissioned blockchain, it is a private blockchain, only a consortium or a group of people uses this blockchain. So here the state machine replication is done, where the state of the smart contract is shared, and the copy of the state of the contract is saved at all servers, at those servers, those involved in the execution of the contracts, and then further it can be replicated and distributed for the updation by different other nodes in the blockchain. In a permissioned blockchain, the network is closed. The nodes know each other. If we take a public blockchain, nodes are not knowing each other. In this permissioned closed chain where nodes know each other, state replication is possible among the known nodes. So in this case, mining is not required, which avoids overhead of mining. As we know, mining and then validating is a big thing in the blockchain technology. We know proof of work mining is a very high computing power consuming work. That idea is not encouraged in case of the permissioned blockchain. So since nodes are know each other, it is suggested to avoid overhead of mining. Do not spend power, time, or Bitcoin other than the power required for message passing. However, consciousness is still required because machines can be faulty or behave maliciously. That's very, very important. So, in this case, we use the distributed consciousness. If a decision maker is only one, then no consciousness required. When decision makers are multiple, consciousness is required. And when different people, stakeholders of the business has to approve the agreement state of the smart contract, then distributed consciousness is required. Therefore, reaching an agreement in a distributed computing is in a closed environment is easy. In a open environment, it is difficult, but we have different consensus algorithm to handle them. Replication of common state to all the processes should have the same view. This is what we call as a single source of truthness in the blockchain. So distributed consciousness finds its application in a flight control system, fund transfer system, and in the leader election or mutual exclusion. Blockchain, as we know, blockchain eliminates intermediaries like a bank. And so before blockchain, our first generation of blockchain also has this concept. In the second version of the blockchain, we came across the smart contracts. For example, Ethereum, which is a public blockchain specifically designed for implementing the smart contract. Another blockchain is Hyperledger, which is for the which can be used for the private blockchain. For example, eLogic Square implements the Hyperledger smart contract for the Cisco. Such things, such works are happening. So in the real world, before blockchain, intermediary exists. In that we call it as a first generation internet business. The second generation internet business, where the internet uses the blockchain for the most of the application, the participants or nodes is highly responsible, and the intermediaries are removed and uses the distributed technology. We can understand that blockchain can be used in the industries for supply chain and logistics, and for healthcare purpose, and in government. So online voting, electricity trading, for example, when we talk about the electricity trading, data diddling kind of thing will happen. We know that the power consumed by some customers, say, is 1000 watts per month. It will be 1000 watts as an input, but while processing the bill, 1000 becomes 100 watts, and the bill is generated. When the bill is generated, so that it is showing 1000 watts only, but the actual amount is for 100 watts. So such a data diddling activity may happen. So people did different, you can see, you can search different papers, and you can go through different governments. And for example, Canadian government is thinking of using the blockchain for electricity trading. So blockchain is also being used for IoT. So a blockchain is also used for healthcare. So because we know that in the electronic health records, so many cyber attacks may happen, and the people may make some changes in the health records. So to avoid that, people are using blockchain based healthcare health record management system. Healthcare, the medical data management system uses the blockchain. Drug development and supply uses the blockchain. Insurance claims, billing, and fraud. To avoid fraud, the blockchain is used. In the medical research also, blockchain is being used. Supply blockchain in supply chain management, as we have seen the many of the cases, since it establishes the trust, transaction settlement is easy. So supply chain uses the blockchain. Audit transparency is possible. At any point of time, no records can be changed. So gives the audit transparency and social responsibility, accurate costing information, better shipping data, because you'll be having digital identity. It keeps recording even the manufacturing of the items as per the specification given by the customer, and shipping, all these things it manages, preventing compliance violations, provenance, and reducing human error. All these are the benefits of the blockchain. That's why people use the blockchain in the supply chain management system. As we have seen the case of ice cream melting, where the IoT devices are being used, even though we have IoT which is providing a better solutions in the various fields like healthcare and in different fields. We know the IoT is having a very large number of devices, and these devices are generating zettabytes of data. These data, whether they are generated properly or whether it is a structured data, unstructured data, we don't have any opportunity to do anything at the IoT devices level itself, because IoT devices are having limited capacity, computing capacity, and storage capacity. Therefore, the IoT data are taken, and they will be processed and placed in the blockchain, and then the data is going to be used in a secured manner. So here also, to implement digitized supply chain management, smart contracts are being used. Blockchain for governance, record management, and identity management, and voting and intellectual property protection. These are the various applications where blockchain can be used for the governance purpose. So to summarize the blockchain implementation for the governance, legal enforcement, where government can use public blockchain data to monitor transaction to facilitate legal transaction and stop money laundering. In the case of bills and payments, governments can impose blockchain technology to improve the traditional billing and payment system. And in the healthcare, government can improve health services by utilizing distributed ledgers. And cyber protection, government can use blockchain technology to protect vital government infrastructure against cyber attacks and hacks. Can use for the land records management system. For example, we know that recently Andhra Pradesh government, for its new capital Amaravati, they are using blockchain technology for acquisition of the land. Maharashtra government is using blockchain technology. Telangana government has started first using the blockchain technology. In Karnataka also, insurance companies, for the insurance purpose, government is using blockchain technology. ICICI Bank is using the blockchain technology. So different governments and various other banks are using the blockchain technologies. Blockchain technology is having these advantages: decentralization, which is an advantage when the distributed ledger is being used, gives the kind of a trust, and these are transparent because everybody is having the same copy of the ledger. It brings the trust. It is immutable because we use the hash, and also before using the blockchain, you have to have the tokens and wallets. Wallets gives you the private and public key, and after then only you can use it. It is available. Availability is good. It is secured, and it is simplification of current organizational operations, faster dealings because no centralized control or there is no centralized processing, and it is cost saving because it is automated and it uses. And so limitations of the blockchain: scalability, adaptability, privacy, regulation, relatively mature technology. Even though we talk about the blockchain is having the various advantages, scalability is a problem because a transaction before a node, before mines or before gives a block of transaction for adding into the blockchain. So it has to solve a puzzles, we say a cryptographic puzzle, and it takes minimum 10 minutes and consumes the lot of power. And if we look at this figure, we can understand that a Bitcoin can have the 10 transactions per second processed. Ethereum blockchain takes can process 30 transactions per second. Dash takes 60, it follows completes processes 60 transactions per second, and PayPal, which is not a blockchain, 200 transactions. And here we think we compare this with the Visa. 24,000 transactions per second are processed by Visa. That means, say, for a kind of Visa applications, if transactions are being processed at this rate, and if transactions of the blockchains are being processed at the rate of 10 transactions per second, so definitely scalability is a big issue in case of the blockchain. Similarly, we have various other limitations in the blockchain: adaptability, privacy, regulation, because we say the smart contracts, the question of standardizing the law and implementing it comes. Even though digital contracts are approved under the IT Act, the smart contracts may also be taken as approved because those are also basically digital contracts with more security and the code itself as the law. But still, the standardization has to happen in the different sections of the IT Act in the India also, as well as at the international level. Different countries are bringing these standards for regularizing the smart contracts. So in that way, the blockchain is a relatively immature technology. We don't have readiness of adopting the blockchain technology in various sectors, but we can climb that blockchain technology by solving these with a different models of the blockchain technology. Definitely people are going to be successful, and it becomes a kind of need to look at the blockchain technology today, because we have seen that China has implemented 6 blockchains which are public in nature and allowing anybody to make the transactions. We know the agenda of the China, but it is going to be a blockchain powerhouse, because we in our blockchain the basic design mechanism will be giving the chance to add a block to the nodes which are having the high computing power. There's also one of the consciousness mechanism or algorithm. So in such cases, we have to design a consensus algorithm which will not give a single person an authority to add the blockchain always. We have to think of various design parameters which enables us to select different blockchains or nodes which can add the node to which can add node to the blockchain. So in that way, different design issues has to be thought. So this is a Gartner's hype cycle. In this cycle, various applications of the blockchains are given. We can find almost all different use cases applications so far. Whatever we have discussed today, we can find in the Gartner hype cycle. Still, I want to make a point that while the blockchain is having several advantages, research and advisory firm Gartner listed blockchain as one of the top 10 strategic technologies for 2020. It said blockchain are presently immature for enterprise deployment due to poor scalability and interoperability, but expects the technology to overcome these issues by 2023. And we should not forget that by 2025, blockchain technology is going to contribute to the 10% of our GDP. Therefore, in this context, blockchain technology is definitely a disruptive technology going to redefine many things, but the actual basic technology needs several improvements and modification to fit into our applications or need. So I acknowledge the various resources that I have used here. So basically, the concepts of Arvind Narayan, computer scientist, Princeton University, Sandesh Shukla, blockchain and its applications available in the NPTEL classes, and John Joseph who was given some good informations from the Faculty of Information Technology, Institute of Technology, Bangkok, and Sandeep Chakravarti, who has worked on blockchain concepts and algorithms with respect to different consciousness algorithms and various internet resources. And also, I thank our principal sir and others who given the opportunity and patiently listening my little knowledge on the blockchain technology. I am open for the questions.
Very good, Dr. Arun Kumar. Very elaborative presentation.
Thank you, sir.
Very important topic, and which is likely to rule the way transactions are handled in the days to come. Maybe to begin with, I'll ask a small question. I have read somewhere and also heard that
Yes, sir.
government of Andhra Pradesh has made a big headway in the implementation of blockchain in its government services, specifically the land record maintenance and so on.
Yes, sir. Yes, sir.
And your comments on that. That is one thing. Second
Yes.
is, China has made a very huge strides in terms of blockchain technologies and has acquired lots of patents in that line.
Yes, sir.
And they have a very clearly set vision for themselves to lead the world in terms of blockchain.
Yes,
And
sir.
they are, I
Yes.
think, miles ahead of other countries. And
Yes,
your
sir.
comment on them if you have any information.
Sir, yes, sir. Sir, I have explored while preparing for this presentation. So Maharashtra is also one of the government who is implementing the blockchain technology. Andhra Pradesh, as you told, for its the new capital Amaravati, they are acquiring the land based on the blockchain technology. So you may also be knowing that in our project-based learning, one of the project that we implemented is the land record registration system using blockchain technology. So similar to that, CDAC also has implemented the land record implementation system where they have claimed they will avoid double registration and to maintain encumbrance certificate EC, they have applied the blockchain technology. Even now our PBL project is also does the same. but they have done the good implementation and showcased to the central government, and they got Golden Project Award. That the same kind of idea is being adopted and being implemented in the Andhra Pradesh government also for the land acquisition system, because maybe it is very difficult to adopt the blockchain technology for the already existing land record system, maybe because of various reasons. For example, some people will make the layout and the records of which 15 years back records may not be available. They will write records are frozen, Shitila Gondide records are not available. So there are many difficulties for that. And when I went to the internship for the Ilaji Square, through them they approached the state government. The Karnataka state government was not ready to take the project, but they are ready to take the blockchain technology for the insurance purpose. So these are some of the things I know with respect to the state government. As you told rightly, with respect to the China is going to be a superpower not only in other sectors, even in the blockchain technology. They have openly said 6 blockchains which are public in nature they can use. When they say 6 public blockchains, anybody can access, anybody can make the transactions, and anybody can use those blockchains for different purposes, including the businesses of the smart contract implementation. So during that time, we don't know how the China may take our confidential records of the business purposes records and misuse it. We don't know, but as of now, it has opened 6 public blockchain for the use by everybody, sir.
I asked that question when you said, your blockchain technology is, still in the premature stage and lots of things have to be resolved.
Yes,
and then how is it that, Chinese or maybe even Maharashtra government or Andhra Pradesh government are able to implement it, specifically China, so widely?
Sir, it's the even though the standardization has to be done, the law or standardization can also be jurisdictional. So China themselves are having their own clear stand with respect to the smart contracts, and they are using it already. So we also have the you may be knowing, sir, when Arun Jaitley was the minister, blockchain was accepted, government appreciated. Now even in the Niti Aayog also, our government has appreciated the blockchain technology and its limitations, its consequences, design problems. It has discussed right from the university sectors to different sectors while implementing the blockchain. But the standardization has to be done in certain countries, and standardization like China, they have already done and they have implemented the smart contracts, because many open sources are also available like Ethereum and Hyperledger. Only certain problems like scalability they have to solve, and China has invested a lot with respect to the blockchain, and they are becoming the computational power hub with respect to the blockchain.
Okay. Thank you.
Thank you, sir. Any other questions?
Thank you, sir.
It comprehensively covered. It was nice.
Thank you, sir. Thank you.
Yeah, if there are no questions, let's adjourn the meeting. Yeah, thank you, Dr. Arun Kumar. It was a very good presentation.
Thank you very much, sir.
You can possibly explore, if we can implement it on a small and demonstrable pilot case at BMSIT, if we can.
Sure, sir. I will try, sir. They will do it.
Okay, then.
Thank you, sir.
Thank you very much.
Thank you, sir.
Thank you, sir. Thank you. I thank all the participants. I thank our principal for giving the opportunity. I thank Dr. Sanjay, Professor Tibali, for coordinating with this and helping me to present. Thank you.
Thank you, sir. Take care.
Thank you.
Yes. The next presenter will be from Bharati.